you, Matteo. So, Michele, we are going to talk about how to document your research software.
Yeah, very interesting, very important thing, I would say. Yeah, very important topic. Yeah.
So this will be a 2-hour lesson that runs up until, depending on the time zone, here for us it's up until 11 o'clock. And in the first hour, it will be mainly that we'll go through things here based on our lesson material on the web page, and then it will be a little bit more hands-on in the second hour. But there will be a lot of discussions also over the shared document now during the first hour. So we could just give a little bit of an overview. So we'll talk about documentation in general for a project, for a code, and also then touch upon some specifics, as for instance, how to write a good README file. What we'll be talking about will be independent of programming languages. Some of the examples will be in Python, but it's essentially transferable to other programming languages. We will learn about a documentation generator, Sphinx, which is often combined with an online service, Read the Docs. And we will also then, towards the end, talk about how to get things to get documentation up online on a service like, for instance, GitHub Pages.
Yeah. It's quite a lot of things to go through.
Yeah. There are a few things, but I think we have time to cover things here. So yeah, perhaps we could first just start a little bit on see what people have written here in the icebreaker question in the shared document. I could.
Yeah, it's always funny to, these are typically very funny questions, and
yes.
People come up with very funny answers, I think. Yeah.
So I'll brought this over here to the screen share, and okay, what do you want to be when you grow up? Veterinarian.
I like become a scientist. I like that. The sense that it also applies to me in a sense. Being a research software engineer means that I'm always between, doing software and doing science, and I want to do both things. Let's say more of both things, and so become a scientist and I would say also a software engineer. But I like that. Yeah, that I can relate. Say.
Oh, here's one, a funny one. Streamer. The stream is teaching and mentoring kind of stuff.
Well, join CodeRefinery, I guess.
Yeah. Yeah.
So for reference, I'm the one that wrote that one.
So. I see. Okay.
Okay.
Yeah.
Yeah.
And how to explain your current job from someone from the year 1700. Yeah. Forecast the future. Yeah, I can always try. Okay, so moving down here a bit, we come a little bit closer to the topic here of the lesson. So, what's the best documented project you have seen? And highlighted here are, for instance, NumPy and SciPy, which are mathematical libraries implemented with API for the Python programming languages. And here,
I think we will see how to write documentation that looks a bit like that. So at least we cannot teach you today all the good practices, but at least we can teach you the tools, or show you the tools at least to do something that looks like it at least.
Yes. So okay, there are the placeholders. So let's move now to the lesson material here. So the idea is here that we will start to be interactive here right away. So we would like to bring up this. I mean, why would you like to document your code and why it is important? So you can see here these questions, and we would now ask you to please contribute with your input in the shared document. And we have here some starting questions for discussion. So the questions are: is project documentation important, and why is that so? How would you describe a useful documentation? And the third thing, how can you motivate your colleagues to contribute to the documentation?
So I can start saying a bit of my opinions here, perhaps, I don't know, to stimulate a discussion. Well, of course, I'm seeing already some interesting answers there. So I will try to say something that is not there. So I actually, for myself, I want to document the code also because I typically do many things at once, and maybe there are some projects that I need to stop for a moment and then pick them up later. And if I have good documentation written, at least I can get back to it. But of course, if I want someone else to use the code, then yeah, but then it becomes more complicated, I would say. But still, yeah, that's a very important aspect of it. So yeah. Yeah, and actually there's a comment which is interesting. For no one is going to use it, not even yourself, perhaps not, but yeah, so it's true. Throwaway code exists, but yeah, with throwaway code is awesome because you can do whatever you want with it, and you don't pay for your sins. But yeah, we are talking about here. I think we are talking about code that where you don't have this luxury, let's say, of throwing everything away.
And it could also be that even if it's a code you write it and perhaps just for use over a shorter time or so, then I mean, to document it can also guide you in the development of the code itself, and perhaps you come to think about some constructions which are not so good, and you then, while describing them in text, in documentation, you then come to think about these shortcomings, and you then improve in the code itself. So yeah, we could highlight here what you have contributed with here in the document. Yeah, here, important here, we need at least a bare minimal documentation, like a README. And I think that's a very important point. And here, like, there are so many steps in the project that are stored only in your head initially. And you need to get them down on paper before you step out away from a project.
Yeah. I think we should try to comment a bit on the third question, like how can you motivate your colleagues to contribute to the documentation? But I think even before asking this about your colleagues, but how can I motivate myself to write documentation? And I think that yeah, so getting familiar with the habit it's important, and also with the tools that are available for that. So I think yeah, the habit is more important than the tools, but yeah, I think that's the way we structure our lesson, basically talking about simple tools first and describing the things you need to think about when you write documentation, and then talk a bit more about the tools later. Right.
Mm-hmm.
Yeah. But yeah, I think that someone is writing an interesting comment here, like learn to do a little bit at the right stages. It doesn't seem like an artificial choice. Yes. So the point is that you can always learn a bit, improve your practices, while you also do some like important work at the same, like the fundamental work of writing the code and doing your research at the same time. You know. Then you stop for a moment, you learn a bit more about how to do things better and go on. So in this iterative cycle, and I think that this is a key to the practice that applies here, but to documentation, but also to best practices in general. How do you learn how to apply best practices in general?
Yeah. I think we can perhaps see here, there are some things which we had here in the lesson material. Let's see, that we had thought of up beforehand, so to say. And this perhaps complement here, and there are some points here that complement actually what we have on the shared document. So you may want others to contribute to the code, and to that end, having a documentation can be helpful, because that can get persons to have a more smooth entry to the code and to the project. The fourth point here is, that's actually a very important point, because shield your limited time and let the documentation answer frequently asked questions. And the scale of things here matters a lot. So if you are working, let's say, 3-4 persons, perhaps you even sit in the same corridor, and you have lunch every day, then clearly a lot of let's say, keeping track of things can be very informal, perhaps only in voice, and you don't need to write it down in paper. If you start to share a scientific code with people who are not at the same physical location as you, and also the numbers go up to, let's say, hundreds of users, can be tens of developers, then clearly you need to do it in writing, and also this with, let's say, the efficiency of things, namely this, that things should be possible to grasp for newcomers to the code. Be they users or be they developers, that is helpful for them, and also quite helpful for people who are already on board, because then you don't need to answer the same question over and over again.
But then the question, I guess, is what would you like to have in a documentation, right? So what are the things you would put in your documentation? So that's why we have this question about the wish list, right? So what is your wish list regarding what you have there?
So one important thing here is that documentation can come in many different forms, and one way of, let's say, categorizing them, which has gained a lot of traction, is to distinguish in the 4 categories of tutorials, how-to guides, explanation, and reference. So we have here also a few reference material for this, and we could perhaps just move quickly to this page here. So here you have like a nice box here with these 4 different kinds of documentation. So a tutorial, that would be something which is learning oriented. So that could be like an entry point to get them started with the code. How-to guides, more like you have something very specific. You have a specific thing you would like to do with the program, and you would like to go in and then get a suggestion on how to do a certain task for a specific purpose. That relates also then, I mean, tutorials and how-to guides, I would say both of them will interrelate quite a lot to more like explanation material, which could be material which are explaining the program and the code itself. It could also go, let's say, beyond the code itself, in a sense that could give, let's say, an overview of, the scientific field, and put it into context when you're using the code. And fourthly, here you have the category reference information, and that is yet another category, that can be then very, let's say, technical, in a sense, could be like an application programming interface, complete description of the API, which then is important for you as a developer of a code to have available. But it can also be then for users that you sometimes need to be able to just find, sort of like in a dictionary style, a complete listing of all of the, let's say, keywords, if it is a keyword-based program, or if it's a graphical user interface program that you have, let's say, a little bit an overview of, here are all the entry points and work modalities in the program. And we will come in a little bit later into the lesson. We'll talk about README files, which I think that's probably something that you all are familiar with. But before we do so, we have here a little bit a task here to come up with ideas for what would be points, suggestions on points to have on a wish list for good documentation. So we have these 3 questions here to start the discussion, and please then work in the collaborative document. The 3 questions are: let us create a wish list for how we would like documentation to be. We do have some of our ideas, but please don't look on them yet, but come up with your own. And also, you'll probably come to think about some things that we did not think about earlier.
Yeah, how does documentation need to be in order to be useful, in order to be useful to different people, and also, well, I don't want to give away too much. I don't want to stimulate the discussion by creating some kind of bias, but yeah, okay. But I see that comments are coming in. So yeah, working examples, like examples on how to use the code. Great. I think this which is really reasonable. A table of content. Yeah, we'll discuss how to get a table of content. This can be typically automated, actually. So we'll see that. Yeah. Yeah, I think that template input idea is similar to like an example of usage, right? So it falls in the same category. I would say possibly in the category of how-to guides, perhaps, or tutorials. I think. That is there. A template input would be possibly part of an how-to or a tutorial, right? think there's a comment coming through about language. I guess one should try to be as possible, as unambiguous as possible. I guess, if I understand correctly, the intention of the writer.
Yeah, that's obviously very important to avoid any, let's say, confusion to the extent possible, because I think it's inherently so that for larger programs, or it could be like program packages where you have, let's say, one main program and you have a number of libraries that you're also using, then there is a lot of complexity, which you can try to shield the user from it up to a point. But I mean, there are often situations where you need to get under the hood and really know what is going on in the code. And then there will be details, for sure.
I see very interesting comments here. But I'm also curious to see what's the reaction to our suggestions.
Mm-hmm.
Right? So,
yes.
Would you go to our?
Yes.
Shall we start discussing our suggestions?
Yes. Yeah. Let's do so.
Yeah. So I think possibly the reason why this documentation, this is part of this workshop, and we spend so much time on version control, is because I think that documentation should be version controlled. It's easy for your code to change in a way that it's not synchronized with your documentation. So if you put the documentation and the source code in the same repository, then it's more likely, it's still possible to have some kind of issues with synchronization, that your documentation describes an old version of the code and the code has progressed, but it's harder for this to happen, or at least it's easier to see that in a sense, right? So I think so the idea is so your documentation should be version controlled, because it will change over time, because the software will change over time. I think also it will change because the documentation can change, because you may find ways to rephrase some sentences, or you will find more fitting examples, and so there are different ways, different reasons why documentation may change. So you want to keep that under version control, I would think. Okay. And so it should be close to the code, I think. Then, what about a standard markup language? What is this about?
Yes, these are something which is used a lot for rendering of contents of text and documents. Often in the context of web publishing, but also for documents that you have offline. And these are, the markup language is something which can be, when you read it in source, in its raw form, it is pure text, which means it suits itself to version control. At the same time, you can then on the fly in an editor, for instance, as Visual Studio Code or other programs on your local machine, you can also render it very swiftly, often on the fly. And we will here, in this lesson, we will see two examples, namely restructured text, RST, and also the so-called markdown markup, markdown, which is sort of a play with markup, as in HTML.
Yeah, so it's a kind of it's very simple. The thing is, who doesn't love Markdown? It's very simple to use, and and it was created with that intent. Restructured text instead is a bit more complex, but it's more powerful. So
Yes.
Yeah.
Okay, what more do we have here? We have copy pastable. That's very practical, I would say. You have, let's say, some suggested sequence of commands, and you can take them directly from the documentation, and then you just paste it in, let's say, your terminal window or other application interface, and things get running.
Yeah, and the problem is that if you use PDF or even some slides, when you have some codes written in slides, if you copy that and paste it, it doesn't work, even if it, even if it looks good when you paste it. So there are weird things happening sometimes. So, yeah.
Okay, I think we should go over these things here a little bit swiftly so that we can come to README files. So installation instructions, that's very relevant. Code licensing, that's
a big thing.
Yeah, that's a big thing. The last point here, information for contributors. That's also something that lowers the hurdle for newcomers, and also a means to where you can, let's say, make clear that that you welcome contributions. And that also depends where you stand in a project. Perhaps in the beginning it is, let's say, essentially closed shop. You work with your team of close collaborators, and you're not really ready to let in other people, and that's perfectly fine. But then you could also perhaps be transparent about this so that there are no misunderstandings. And what I do myself sometimes is that I simply, reach out over email to people to check first, like, okay, is here something you would like people to contribute? It might be better to have that kind of conversation offline rather than to have that in let's say, discussion on issues in GitHub.
I actually have something to add to the wish list, which is not on this list because it's a bit hard to achieve, but I think it can be nice. So I think that there's some kind of documentation, there are some formats that allow you to check at least part of it automatically. And so if you write documentations using a notebook approach, like a literal programming approach, there are some tools that actually can verify that your tutorial that you write in like a Jupyter notebook in this way, when you mix text and code. So if you use that format, there are tools that can validate your documentation in a sense, so that you can actually run them automatically and see if something has changed. And I think it's nice to have something like this because it allows you to basically maintain your documentation with less effort, or to at least detect problems, incompatibilities between the documentation and your code quicker. And so when we're going to talk about Jupyter notebooks this afternoon, and we're going to talk about automated testing tomorrow. So I think this is a good way to connect the dots of all this. I have a narrative, overarching narrative in this huge workshop. Yeah.
Yes, indeed. And you mentioned, Neil, that there are different tools and frameworks. So that brings us naturally over to a little bit that particular topic, namely, so what tools and solutions are out there. So when you do commenting in documentation in code, there are things that you can do, which could be like pure comments. You can use function doc strings. And naturally, the in-code documentation is a primary concern for the developers of a code. It can also be of high importance for users of the code, if it's so that you have something which is, let's say it's something, big simulation software with a lot of let's say details in the implementation, and where you as an end user need to know precisely what is happening. Sometimes looking directly into the source code is the adequate thing to do. And then having the in-code documentation is important, because that then you can, as a guide for the eye, so that you find.
Especially if you're talking about like the kind of functions that stay a bit on top of everything. So the more the functions that the user may call, then I think these are the comments there and are going to be pretty useful, because I think these are the most likely to be looked at by a user, right?
Yeah.
I want to say one thing about commenting your code. There's a number of people, like a discipline called clean code, where they say, code comments are not great because they are hard to verify. You should actually name your functions and your variables in a way so that it's obvious what they done. And I think that it's good advice, but it's quite hard to get right. So yeah, yes, we need also comments in the code, I think. Yeah, but I think there's also people that say, no, you shouldn't comment your code. You should make your functions and your variable named in a way that you don't need comments. Maybe it's possible. I don't think it's always possible, but yeah.
Yeah, it depends a little bit also on which language you're using. Because I mean, some languages are more verbose and let's say human language like-ish, and whereas others are a bit more compact and keyword like-ish, so that you need to decorate it, or you could naturally decorate it with normal text.
Okay.
So we had mentioned here earlier already this with restructured text and markdown. So, Michele, what are these formats?
So yeah, here in the notes you see. So basically, there are two formats that allow you to write. They are really already readable as they are, especially Markdown. I think that was the design. Like the design goal of Markdown was you don't have to render this to HTML. You don't have to render this to a web page. You can actually read it as it is. You see that you have different features here. You can make some parts bold. You can emphasize some parts. You can have like lists. You can have images, tables, links. And they are like equivalent in the basic functionality, at least, right? So restructured text is a bit more featureful than Markdown. Markdown has actually different flavors. So GitHub, for example, can render Markdown files. It will do that in a different way than the GitLab, for example, at least on the more like niche features. While instead, restructured text is more standardized, and it can also be expanded if you want. You can add, if you want to do something fancy, you can create new directives and new roles, and there's a mechanism to do that. With Markdown alone, it's a bit more complicated, but Markdown is simple, and people don't need to be taught how to use Markdown, while people may need to be taught how to use restructured text.
That's a good point. Indeed, Markdown is very lightweight, so essentially you can copy paste some paragraphs and then as a starting point, and then you already have the syntax there for everything, and you just write your content.
Yeah, and actually in what follows later, when we are going to talk about Sphinx, we are going to use something which is the best of both worlds, which is MyST, which is like a markedly structured text, which is a flavor, like a Markdown flavor, which is expanded in a way that you have also the restructured text features.
So you see here in the middle here of this panel that have some references here where you can find then more details on Markdown and on restructured text. HTML static site generators. That is something that we will try out in the second hour. And as you can see here, there are many options available here. So yeah, we have Sphinx here, Michele.
So Sphinx is like the main tool that is used to document the offshore Python projects, and that's what we're going to use here. So we said that at the beginning that this part is like language agnostic, and it is, because you can write any documentation for any project of any language. But yeah, we're actually, I mean, this is actually Python. This is a Python tool, okay? But a lot of, but this is only for the Sphinx part. What we're going to talk about in the first hour applies instead to basically every software project in any language. And yeah, so so there's really many of them. I think the mkdocs is becoming more and more popular. And the cool thing about Sphinx and mkdocs and also others is that they can do things which are really interesting, not just generate HTML, so web pages, but they have plugins where, for example, they can produce PDF or LaTeX, or they can parse your code and extract the doc strings from it, okay, so that they can generate an API documentation, reference API documentation. And so this is about Sphinx and Markdown, mkdocs and many others, which are a bit more language specific because they need to read things from your code, so they need to understand your code. And the thing is that after you have used this tool to create a web page, you can host it. You can put it on the internet so that it can be seen from everywhere in the world. And we'll discuss about how to do this on GitHub Pages later. And I think that, do you want to add anything here? Is there anything I'm missing?
No, I think that was a good overview. You could briefly highlight some other frameworks here. So wikis, as pioneered by the wikipedia.org website. Those are solutions where you have, then you can produce contents a bit dynamically, with having people to jump in and contribute, and essentially the editing of wikis is done on a web browser, so you don't really need to you just need to go from view mode to edit mode, and you can contribute. So that's an advantage. But I would say my personal reference from Wikipedia, from wikis, is sort of that in order for them to become good, you also need to have a lot of, let's say, you need to have some editors and some moderators of content, because otherwise it's a little bit uncontrolled how they develop over time.
Yeah, but the problem with wikis, I think, that it doesn't fit with the first item in our wish list, that they are not version controlled. So they are to an extent version controlled, but they're not version controlled with the code, because it's typically a different repository. Actually, it's like a different repository. So that's why I think they are easy to use typically, but it's not what a research software engineer or a software engineer would use to document their code. I think you have maintainability problems then.
Yeah, it's not like that. Was for me, that would not be, let's say, a primary choice. But certainly wikis can be a very good complement. LaTeX and PDF, those I would say are it's a little bit old school, which can be perfectly relevant, in particular if you are working with a lot of equations. Because then LaTeX is the best tool. Yeah, the rendering to contents can be a little bit. It's not always so smooth to work with for, let's say, live documents on the web.
Yeah. And write your papers in LaTeX, but please give us something else to understand your code.
Yeah.
That's my opinion.
Yeah, I agree. Docs again, and we will not look further into it here, but this is a tool which is very popular in the C++ community, where you can decorate your code with some keywords, and you can then from that source, like in the source code decorated with these Docs.jn keywords, you can then generate documentation for the classes and objects of your code and like the programming interface.
I think it's one of the oldest tools that does API reference generation. Like as I mentioned, Sphinx can do it for Python code, for example. Docs.jn can do this for C++, for C++ and C and other languages. I want to say that if you're using C++ or the thing, you possibly need to use Docs.jn to generate this, but you can still use Sphinx as well, because Docs.jn can actually talk to Sphinx with a plugin, a Sphinx plugin called Breathe. So yeah, if you are a C++ developer and you like Sphinx, but you need to use Docs.jn, then you can also put these things together if you like.
That's a very nice opportunity that one can do this. So there are, Docs.jn is popular for C++, but also for some other languages. So you can find here some specific frameworks which are of relevance for Fortran and for Julia. And there's also an interesting tool, Quarto, to convert Markdown to various document types. So let's move over here to the topic of in-code documentation. And here, so now, we are doing this lesson here in streaming, but we will not have any separate exercise sessions in between. But so we will highlight a few things here, and then we very much encourage you to sit down at another time, so to say, and then work through these exercises. And you will then find also some template solutions. So,
in this particular episode, I think it's more discussions, right? So, but yeah.
Yes, that's you're right. But nevertheless, if you have time, later today or so, then please go ahead also to do the exercises. So here we have some examples here. This is about an if statement, has something to do with temperature, and Michele. So what?
So yeah, basically, if you see, so there's a check. So if the temperature is less than -50. Then we do something. And now if you look at comment A, I think, okay, now we check if temperature is below -50. Okay, if I didn't know Python, then I would really, okay, this comment would be really helpful. But if I could read Python already, I thought, okay, so that's exactly what that if statement says, right? So it doesn't give me more information if I know what Python syntax is, okay? Actually, it's also good that we use the temperature. So the variable temperature is called temperature, because then we know what it is. There are some codes where all variables are called A and B, and then in that case, that comment would be helpful. But in general, I would say that comment B, like we regard temperatures below -50 degrees as measurement errors. yeah, I think it's a more. I like more that comment. Although I would really love, to be honest, to have an error like in the print statement. Error is temperature too low. I would possibly put that. So I would write in the printf in this print string. I would say it's a measurement error, something like this. But yeah, that's at least my opinion here.
Yes, that's very good points. And
I think that writing comments and making readable code is a bit of an art, and I don't think I'm good at it. So my suggestion is always iterate, right? So write something and then go back to your code after a while when you have time and see, maybe you first start with version A, and then you realize, oh, but I mean, this comment says something which is obvious. Maybe I can change that to version B to see. But yeah, so you can do it like incrementally. You don't have to start and do things perfect on the first time. But I think that, yeah, to me, it's a reason. So this example, comment A and comment B are like a realistic progression of like how you can improve code and comments if you iterate on that, if you go back to your code. And
and one could also think that perhaps this the comment of the type A is like, now we check if temperature is below 50. Let's say you half a year from now that you revise this if statement, and let's say you check also, is it below a temperature or is it also above a temperature, something like that. Then I would say it could easily happen that that the code and the comment becomes out of sync. A comment of the type of B is more like, okay, here's like minus 50 degree check, but you could also then, let's say, this is about defining what intervals could be considered to be reasonable in the first place. So here's an interesting comment here in the lesson about so-called zombie code, that you take, you have some old implementation on some functionality and you comment it out, and then you replace it with some new code. And the advice is here that, I mean, you should strive then to remove the out-commented code, and then, I mean, you retain it by means of the version control. But it's good to hide it away to avoid clutter. I must say that I find this a little bit difficult in practice, because I somehow feel more confident if I have the zombie stuff in the code. I mean, within reason.
I think it depends. So if I'm doing some quick changes, yes, then I would keep the zombie code but if not, I would, I mean, if it's something more long term, yeah, then I would use version control. Maybe you can even say, I will, I can do like patch staging. So git add -p and choose only, basically I can say I want to add only the parts which don't contain this zombie code. So there are options there. So version control gives you a lot of options there if you want to be like clean, let's say.
Yeah. So here is something which is called docstrines that we could say a few words about, and that's that. I mean, various languages support. I mean, have implemented constructions for self-documentation of features. So if you look here on this Python snippet here, We have it here described first as like a pure comment in the code. But you could also put like the description on what this function is doing in this more like API documenting style. And this connects a little bit to the kind of output that you can get if you have like a program that you're executing it by typing the name in a terminal window. You then often have some flags to steer the execution of the command, and one of the standard flags is --help. And if you then have the command name --help, then the contents which you have like in docstrings is what then will be shown.
Yeah. And also Sphinx and Doxygen can actually, take this, extract this docstrings and create the API. So, yeah, API documentation.
So I'm looking here on the clock here, Michele, and I think perhaps we could do like this: that we spend some 3-4 minutes here on README files.
Yep.
And then we will be at a natural point where we go for a break, and then after break we can then start with Sphinx.
Yep. Okay.
So writing good README files. So what can we say about this? So what's your experience, Michele? What would you like to see from a good README file?
Well, so as people have mentioned, I think a good README file, it's a part of the documentation, right? So, but I think it shouldn't contain the whole documentation. Sometimes it's like it's nice to split it into different files, if possible. There is a catch there, but yeah. So, for example, having links in a I think as a feature of Markdown or of general like technology that you can use when you write README files. So, and it's also nice to have some kind of markup that says, for example, this important part. So it's nice to have like, so it's mentioned here in the first exercise, which is walkthrough, like you can actually specify some, like some, that some parts are more important than others. Yeah, and you can have images, and you can also have like badges. Like the one that is shown if you scroll a little down in the notes. It can be useful to have some badges to signal like okay, my code has passed all the tests, and you can have a badge there that says that is red if the tests have failed, or can show also the license right away, what kind of license is there. So there's many different badges you can put there. It's a bit eye candy, and I think some people find it a bit of a gimmick to have these kind of things, but it's nice. I think it's a way to signal things. And actually, the README file you have in your repository, on your GitHub repository, GitLab, whatever, is like the entrance of your front door, right? So that's what the first thing that people have the people see when they look at your repository. So yeah.
I was from my experience, I prefer a lot where the README files stand on their own. So certainly, I mean, you can have links, you can have badges, but it's also good if, I mean, just the README file in itself, without following the links or without clicking the badges, if that can tell you upfront. And that could also be sometimes, let's say you work on the login node of a supercomputer, then it could even be that you cannot really click the link because you don't have a web browser on that login node.
Yeah, true. Yeah. But it can tell you, for example, a link to other files in the repository. For example, the contributing guide it can be actually linked in the README, although maybe it doesn't need to be linked because typically it's written in a file which has it's called contributing.md, or the installation guide. Yeah, you can link it from the README if you wish, but it's usually called install. So you can actually, so that is this kind of standard file names for different kind of documentation. The README is one of them, of course, and it's the most important in this case. And you could put links to those if you wish, if it's relevant.
Yeah, and certainly this with having different file names, like you can have README, you can have install, you can have contributing. That's these standards are quite useful because that makes the reader find the specific content very quickly. And that's something I appreciate from a README or from an install file, is this if we can get a grip on it within, really like 30 seconds or 1 minute. Because could be on some days that you're looking into 5 READMEs for 5 different programs. And the more clarity you can have upfront, the better.
Yeah, and it's actually interesting here as if you have detailed descriptions, you can actually use this details tags where you can actually hide some long things, so some long descriptions, and just show a short summary in this case. And it's actually interesting because this is an example of a feature of Markdown, which is that you can actually put inline in the code, in your Markdown code, let's say, but it's a document, you can put HTML code. This is actually HTML if you look at this. So there are HTML tags, and yeah, you can use that in a Markdown file as well, and it should be rendered as expected, as if it was HTML. Yeah.
So if you are on this page of the lesson, we can just, so this first block here was actually we had it labeled as an exercise, and you can also find 2 other exercises here in this section of the lesson. I think that we will now shortly go for a break, and I'd say that this exercise number 2 and exercise 3, the suggestion is here that you could come back to this on your own later, and there are good template solutions here. And now after the break, we will start the topic of documentation with Sphinx and Markdown.
Just one thing about these README exercises. Well, there's going to be a bring your code session. There are going to be bring your code sessions in the next weeks. So maybe that's a thing that one could, discuss in those sessions.
Yeah, that's a very good. Yeah, thanks, Mikael. That's a very good suggestion. So let's just very quickly move over to the shared document to see what we have here. Oopsie.
Let's have a 10 minutes of a break.
Mm-hmm.
So
yes. So
shall we convene at 12 past the hour?
Yes, that sounds good.
Okay.
So yeah, see you all at 12 past the full hour. Bye.
On.
Hello. We are back. Okay. So, did you have a refreshing break, Johan?
Yes, I was filling up with coffee.
Coffee, yeah.
Yeah.
There's a lot of jokes about coffee. I don't remember any at the moment, but yeah, we eat coffee. coffee. So so we'll do a more hands-on-ish part of the lesson at the moment, right? So now we are switching to how to use Sphinx and Markdown. So I'm showing the notes now. There's a link in the note which should point to the part that we're going to talk about now. And so I will, since it's a hands-on part, I will show a lot my shell, my terminal. Okay, I'm going to switch to my terminal now. Okay, so you can see the terminal it's all glory. So for this part, for this hands-on, we are going to use a Conda environment. I don't know if anybody has used it before during the workshop, but yeah, so in the installation instructions for the workshop, it was discussed how to set up a Conda environment. It's a couple of commands, but you need to have Conda or like the Conda package manager installed on your system at least. Okay, so the cool thing is actually that with this setup, well, if you're not ready now, you can still watch rewatch the stream later after you have set up Conda if you haven't done that. But let's assume you have done that. Then you can follow what we are doing now. So what I'm going to do now is to show you how to use Sphinx. Sphinx is one of the documentation generators that we have discussed before. Okay, it takes Markdown files, structured text files, and then generates different kinds of documentation out of it. We are going to focus today on the HTML kind of generator, the web pages kind of output, because it's the thing that we can publish on the web most easily. Yeah, so Sphinx is a Python package which is actually present in the Conda environment for CodeRefinery. So I'm going to activate the environment of CodeRefinery. Yep. Now it's up. It's active. You can see that my I didn't want to do this. So you can see that my prompt has changed, and now the environment, which was previously the base one, it's now switched to CodeRefinery. Okay. So just to check, what kind of version do I have here of Python? So now I have 3.12.9. It's correct. For you, it could be slightly different, but it's still fine as long as it's like 3.11, 3.9. I think up to 3.9 should be okay. Okay. One thing we need is Sphinx build. Okay. And let's check the version. The version I have is 7.2.6. It's okay. At least this command has run without errors. And the other thing we want to use is the quick start tool. Sphinx quick. Okay. And let's check the version. Yeah, so it's similar to the previous one. And we also want to check if the parser we're going to use, so we can use the so-called MyST, so the markedly structured text parser, so because that's the format we want to use to write our documentation. Okay, and in order to check that, we can use Python -c. So if you use Python -c, it's going to execute the program that follows in the double quotes in this case. Import MyST parser. Okay, this is the shortest Python program ever, just one line, which imports this. And if there's no errors, it's fine. So, and I have no errors. Okay.
So I could perhaps just pitch in here. So if you want you're very much encouraged to type along with Michele, but if you for some reason do not have the Conda environment available, then you could also just, relax and listen in.
Yeah, I will try to be entertaining and funny, so that at least you won't fall asleep. Yeah. at least try to keep up the discussion as we did in the last in the previous part, in the first part. So now we have verified the setup, okay, and we can start hacking at our documentation. So I will create a directory and seed into it. Doc example, okay, and now I can do Sphinx quick start. So quick start, and this command now will ask me a couple of questions. Here it will ask me if I want to separate the source and build directory. I will go for the default answers. So yes, project name. I will say test documentation, and then also name.
So you choose no. So you will have them in the same directories.
Yeah, it's at the moment should be okay. What was the recommended thing? Yeah.
Yeah. No, it's perfectly fine.
Yeah. And yeah, so actually I don't have a lot of experience with Sphinx. I have some, but I know that Johan has more. So I think that Johan may correct me if I'm doing something wrong. Please do. Project release 0.1. It's okay. And then the project language is English. Let's try that, even if it's not my native language. So now you can look at at the content of the. Let's clear here. Shall I clear? Maybe I don't have to. You can see what has been created. You remember that this was actually an empty directory, and now Sphinx Quick Start has created all this stuff for me. Okay, and there's some things we could talk about, but the most important are actually this. I think this is this index.rst. Okay, RST is the extension that stands for restructured text. So let's have a look at it. In order to look at it, I will use Vim. Okay, so if you don't know how to exit Vim, ask in the notes, and if you get trapped. But maybe you can use anything else. I use Vim because I'm comfortable with it. But you can use Nano, for example, or Cat. Even Cat is not an editor, but you can still see. So what does it say here? Well, it says, it gives us like there's a comment at the beginning. This is not going to be printed out. Okay. Then there's a heading. Then actually this is a directive in reStructured text that tells the Sphinx to create a table of content there, TOC, table of content. And so what we actually want to do now, okay, is to remove for the moment this indices and table section because we don't care about that. Okay. Thank you very much, Sphinx Quick Start, but we don't need that. So how do we add content to our documentation? Well, we need to here add file names. In this case, so I'm going to create a file. So here I mentioned a file name. I need to create a file with that name in my home directory to make sure that not in my home directory, in the directory of the project, and Sphinx will look at it and will render it. Okay, so so we will go to this. There's one comment I want to do. As you may be familiar with, if you're using Python, you know that in Python, white space is important, so that the indentation level is important. Here, the indentation level is important as well. So in this case, I need to make sure that SomeFeature.md, okay, is at the same indentation level as this other block. Okay, so now I can save it. but I need to still do one thing. So in order for Sphinx to be able to parse this kind of Markdown files, I need to edit the configuration of it. So I open conf.py. Okay, conf.py is Python. It's a Python code that tells it's a file made up of Python code that tells Sphinx how to configure itself. So the syntax here is Python, and here what I'm going to do is to add myst underscore parser to the list of extensions. Okay, and then I can save and exit. Okay, and now I need to add some feature.md file. And for in the interest of time, I will copy and paste it here, the content we should have. And you can see there are some Markdown features we are using. So we are we have a level 1 heading, then we have a subsection which is level 2 heading, then we have some items in lists, and we have nested items. Nested lists, right? And you see that actually we have these empty surrounding lines which are required. I don't know if it is a thing which is needed also for Markdown. I think it's also not just this particular flavor of Markdown, but also generally Markdown. You may have you may need these empty surrounding lines around. I'm not sure. Do you know?
I don't know all of these by heart, but it's very important to be aware of this, that both, I mean, like as in general in Python, I mean, spacing, as tabulated spacing are important, and then also here for the generation of the HTML contents, that spacing matters sometimes.
Yeah, so horizontal spacing here, you can see the indentation, but also vertical spacing, let's say.
Yeah. So that's very common error. If the rendered contents do not display properly, spacing is one of the first things to check.
Yeah. So I'll save that, and then let's have a look at what we have in the repository. You should see, let's say ls-1, so that we see everything in a column. And yeah, okay. So if it looks like this in your directory, then it should be fine. Okay. And yeah. So now, how do we build the documentation? Let's do this. Sphinx build dot, meaning the current directory. So we want to build documentation which is in the current directory, and we wanted the produce documentation, the render documentation, to be in the _build directory, common choice. So if I now run this command with enter, you see that it tells me, okay, so the HTML pages are in build. Everything looks green, no errors. Okay, good. So now if we look at build, we see that there's some stuff there. The most important thing in the generated documentation is this index.html. Okay, this index.html is the rendered version of index.rst. Yeah, so we can have a look at how it looks like, right? So let's do now open. I mean, I'm on a Linux machine on Ubuntu, so I can use open build index.html. Now we have many windows open, many browser windows open. So where will this go?
So these HTML files that you render now, these are a set of static HTML files. That means for previewing locally on your machine, you can simply just open them in a web browser. You do not need to have...
It didn't work for me. Let's try again. Okay, it doesn't like it. Why? It's interesting. So I'll go to a browser and show you. So this is notes, but if I do in file, I don't understand why it can't work. Let me see. Oh, okay. So wait a moment.
So I mean, having the static HTML files is they are rather smooth to work with because you do not need a web server to host them.
So I need to do some magic. Mm-hmm. Sorry. I need to do, because now the problem is that I'm using a training, so that there's some things possibly I shouldn't tell you. I don't have to tell you. So if Johan can host the show for the next 30 seconds, I may actually fix this and show you finally how our Sphinx documentation looks like.
Yes. So I'm looking now here on the shared document, and there's a question here. So why do you name the directory with a leading underscore build with a dash? And someone has answered here. So it's a convention. So it's not something that is required for any syntactic reason or so, but it's a convention. So when Michele used this Sphinx start command to initiate this Sphinx document, there was this question here about, let me just scroll to it myself. Yeah, the question about separating source and build directories where n is the default. And so one thing within general is good if you are working with rendered content from some set of source files. Right now we're talking about the Sphinx document, but it could also be, let's say, Doxygen rendered contents. Is this that typically what you do want is to have, I mean, the source contents in the Git repository, but you typically would like to avoid to add and commit the rendered contents to the Git repository. And that's rather natural in a way, because otherwise you have a bit of redundancy of having both source and rendered contents, which after all contain the same contents, just it's in raw form or in, so to say, readable form. And this in particular is important in case you are including figures in your document, and if you have, let's say, in figures that you pull in from outside of your core repository. I mean, you do not want to include that in the repository.
I can show you now, I think. Wait a moment. I have managed to find a workaround. Yeah, so that's how our first documentation project looks like. Yeah, so you can see that this is the index. Yeah, so we have some feature. Some feature is actually the let's look at index.rsc. So this is what comes out of this this file, some features.md. Then if I open some feature.md, you see that I have this heading and subsection, and these two headings match what I have here. And if I click on some feature, then I show here, I see here something familiar that looks a bit like a rendering of what I have here. Okay, this is plain text, and this is instead HTML, right? Yeah.
If you go with the mouse here in the document, what happens then? Do you see some links? Yeah.
So
Yeah.
here.
Yeah. No, you have some feature, and then you have subsection, right?
Yeah. So you have.
No, when you're at subsection, if you right click here, you have link to this heading. You can copy the link. So that's an extremely useful feature that you get for free with Sphinx docs. So you get like the direct links to individual sections and paragraphs are available.
Which are typically the page, the web page itself, plus this hash, and then a little something which follows the hash, which is typically the subheading, the link in the page, so to say. The section. Mm-hmm. Yeah. Okay, so shall we continue with the? Mm-hmm. Yeah. So now there's actually an interesting list of things you can add to the to your. I'll actually show because there's a lot of things you can do, right? So for example, you can have additional kind of levels of heading. You can go up to level 4, I think, which is a lot. I think should just try to stay as like level 1, level 2, or level 3. But if you want, you can get to level 4 of nested headings. Okay. You can also have links. We mentioned before, like, and the links are written like this. So if you need to type here, the text that you want to be shown, and then instead in round brackets you type the proper link, the proper address, URL you want to connect. So for example, in this case, you will see a link where the text is a link, and then it will link to this website. Okay. You can also have images. I don't have an image to show you at the moment, but so here, for example, I can show you how to do this. So it works in a similar way. You have square brackets. There you need to type an alt text, which is like the text which will be shown if the image is not available. So and then you have like the link to where to the image file. Yeah. You can also have things like numbered lists, and numbered lists are, well, they start with a number. So the items on the list start with a number. Item 1 is item 1. Item 2 is item 2. But actually, this is a funny feature of Markdown, that actually, if you start going on with 1 dot, these items will be actually renumbered for you. Item 3 and item 4, and so I think you understood what I mean here. And you can have simple tables, so you can can have simple tables written like this. Let's make a bit of like that. It's important to get this heading right, I think, and then you can say, okay, let's have a little thing here. So have a little table that says if a number is prime or not. 1 is not prime, and then I think it's debatable, right? But then you can have 2 is actually prime. So let's yes, and then also 3 is prime, and so on. And most importantly, now come to like code blocks. So that's the following is a Python code block. And then how do you do that? So you start with 3 backticks, then you type the programming language you want to use, in this case Python, and then you can say def hello, and then you can go like that. And then when you are done with writing your code block, you can add another 3 ticks. And yeah, you can do the same with C. You can also include files. I mean, in the notes, it's written in the notes in the material, and yeah, it's written how to add actually literally file from somewhere else. And you can also use Jupyter notebooks actually. So you can have a file of a Jupyter notebook, and you can include it in your documentation if you need. Yeah.
So
Yeah.
So what happens here? I mean, when you label it here with Python or you label it with C, is that, I mean, you would then have this nice, I mean, syntax highlighting in the rendered HTML.
Yeah. Yeah. And one thing it's quite important for audio audience, I think, is that you can have equations.
Yeah.
Yeah. So for example, you can have an math. So here it's a bit different. You have this these braces here, but you can have something like A squared plus B squared equal C squared. Okay, you can have much more complicated things like that. You can also have wait a moment. Yeah, you can also have that in line. Yeah, so there's a lot of things you can do with it, and I think that everything which is reasonable, I think, it's covered by Sphinx. So let's see how it looks like. So if I do a Sphinx build, I will build again. So yeah, it tells me, for example, that this image file that I have added it was not found. But let's see how it looks like. I need to do a little trick again. Yeah.
So in the meanwhile, a comment here about equations. So these can be written in LaTeX format. And that's quite useful because if you, for instance, have some old documents which are written in as LaTeX documents, then you can migrate over directly the equations, and then you put them here into the Sphinx document, and then they will be rendered. I mean, not to PostScript file, but will be rendered to HTML.
This is LaTeX. Yeah, and yeah. So I build it, then go back to my browser. I think, oh, but this doesn't show. Why? Because I need to press F5. It didn't show it. Yeah, because I need to do another little step before, which you don't have to do. But if I do F5 now this LaTeX will appear. Yeah. Okay, so I think.
So what I'm curious. So what happens if you have some syntactic error in the file? I mean, if you by mistake if you change from no to yes in the table, but you then get it, let's say, so that the alignment of the vertical bars is incorrect. What happens then?
So if I do something like this, let's break this.
Yeah,
down.
You break it
let's
and then
torture. Let's see what it happens. Will it work anyway? So I got no additional wordings, so maybe it worked. Let's look now at the rendered version. Yeah. So yeah, it worked.
Okay, interesting. Then it was tolerated here. And this was in Markdown. Okay.
Yeah.
Yeah. Okay. Yes. Then, well, with RST, I think it would not have worked. I don't. But you would then. The point I wanted to make is this: that this Sphinx docs is rather user friendly. So if you break things, you sort of get like a warning message, or you get like an error message.
And one thing I wanted to show you to attract your attention to is I said that the number list will be numbered automatically, even if it's, I wrote 1.2 dot, 1 dot, etc. It will show as 1, 2, 3, 4 instead. Okay, so yeah, it does. Yeah, there are some convenience features also. You don't have to align your tables perfectly because they will be rendered instead by your browser in the correct way. Yes. There are some it's nice. You don't have to be really so a lot of Sphinx understands what you want to do in some cases and will do it for you, right? So another thing I want to possibly just show, because I'm not sure if we have time, is that but I think it would be nice to show this, right? Auto-generating documentation from Python docstrings. Right. I think maybe I can show you briefly how to do this. So let's say we have a multiply.py file, which contains some Python code, which I will now paste here, okay, and save. Okay. So if I now want to add this function to my documentation, how can we do that? Well, I need to do some steps first. So I need to change my configuration, and I need to make it so that among the extensions, I also mentioned a thing called autodoc 2. Okay, so this is an extension to auto-generate documentation. And in addition to that, I also need to say autodoc 2 packages. Wait a moment. And then I can say, yeah, the file that I want to process with autodocs. Multiply.py. Okay. Yeah, because I want to tell autodoc, hey, please autodoc parse this multiply.py file. Okay. And then this is the first thing I need to change. Then I need to change index.rst because I want to Sphinx to say, okay, so now after some feature.mne, I would like you to add call like the API documentation. So apdoc index. So basically, this autodoc will create a file, a directory called API docs, and there's going to be an index in it, and I want Sphinx to include it. So now, if I do Sphinx build, yeah. Wait, it doesn't like that. Sphinx build dot build. Okay, like that. Okay. So with this command Sphinx build dot, I rebuild the documentation. I need to do my little trick here, and then I should be able to show you again this. So let's go to the main page. Yeah, I click here, and then you can see that there's a new thing that's popped up, which is the API reference. Okay, and the API reference of multiply. And if I look into this multiply, so then you see that I get something which looks very similar to the docstring that I had here. So which I will open now. And yeah, wait a moment. So yeah, multiply two numbers, parameters A, parameter B, and return. And that's what I see here, right? So we have the parameters and returns. And this is similar, I mean, yeah, it's similar to what you have in the NumPy documentation, for example. Okay, which may be the fact that Sphinx is used to document a lot of Python projects. You were saying?
Yeah, so it's clear here that if you would like to render in the way that Michele did here contents of this type, I mean, doing it, auto-generating it from the source code itself, from a doctrine, I mean, that's really the way to do it, because if you if you edit this material a little bit auto-sync with the source code, yeah, well, you typically would get auto-sync. So the take-home message is to strive to have it like integrated here with the source code itself.
Yeah, so that it will be easier for you to write it and easier for your colleagues to write it. So yeah, write doc strings, and then they will be added to the documentation automatically, which is something the docs can do for you for other languages. And Julia, I mean, a lot of languages, they have similar things. So if you're not using Python, you use another language, I'm sure that there is a package that gives you this this capabilities feature. So
yeah, indeed,
look for
indeed.
it.
Yeah.
I think that maybe we also mentioned here in our notes in the lecture notes in this. Anyway, I think I would like to move now quickly to the next bit, unless we have some questions. If there are questions, we should always spend a bit of time talking about those. If there's anything specific. Okay. So one thing I want to talk about is this. I will open the material, the teaching material here. So I go with deploying Sphinx documentation to GitHub Pages. So here it's a quick exercise, which which I can show you directly on GitHub. So you don't need to have followed what we've done before. I can just go from here. So we have a documentation example, which is a project template on GitHub, and we can use that to show how to publish things on using GitHub Pages. GitHub Pages is a feature of GitHub that allows you to show the kind of websites that are composed that the Sphinx creates. So static web pages. Static web pages are pages which do not require the web server to actually do anything fancy. They just require the web server to give them, so to give it to the browser that wants to see them. Okay. So how to do that? There's a documentation example repository. I will click on the link. I can do a test GH pages. Okay. Create the repository, and then what do I have here? Everything is being generated for me, and so I have some content already. So the thing I need to do actually here is to add an action. So GitHub has not just the pages feature, but there's a thing which is called actions, which is a way to do a lot of things actually, but in an automated way. So we can tell now GitHub to perform some operations on this repository. So what we can do now is actually, we don't have to start to click here. You can go to the code, and then I can create a file that is that will contain the workflow, the actions that GitHub needs to perform on this repository. So these GitHub actions files are contained in GitHub. Then workflows. This is the standard path where GitHub is going to look for when he looks for actions, and then the name of the file would be documentation.yaml. So this is the file I want to create, and the content of the file will be copied from the material. Oh wait, I need to copy and paste. Yeah, and so we are saying, I will just quickly comment on what are these things. So we're saying, okay, so there's a workflow called documentation, which will be run when someone pushes to the repository, when there's a pull request, and when someone wants to run this workflow manually. This workflow is made out of jobs, a list of jobs. In this case, there's only one job called docs, okay, which runs on a container. It needs a container to start, and the containers were mentioned yesterday. It's a container that is based on Ubuntu, yeah. And then there are some steps here. First, we are going to check out the repository, and to do so, we're going to use an action that has been written by someone else. Then there's another action that says to set up, that is made to set up Python, and this action has been written by someone else as well. Then we had another step, which is the installation of our dependencies. So we have our pip command here to install everything we need. Then we have the build command to build everything, the Sphinx build command. Okay. And then we have eventually our last action, our last step, which does some magic here, which means trying to simplify, take whatever we have created in the _build directory and put it on a new branch called GH Pages. Okay, and this GH Pages is also an orphan branch, which means that it has no parent, and so on. Well, so I can commit the changes now and say create documentation.yml. I would never do this. I would never leave the default commit message, but that's what we need to do here. Okay. And now I have this actions, this action defined. The next thing I need to do is to enable GitHub Pages for this repository. So how do I do that? I go to the settings of the repository, go to Pages, and then I say, okay, build and deploy from a branch. That's okay. Then I need to choose the branch. But first, I need the branch to be created. So let's go to actions first. Okay. I need to, so create documentation.yml. This has actually run. So I should see here, and if I go to code, I should see a GH Pages branch appearing. Okay. Then I can go back to the settings and pages, and then I should be able to select here GH Pages, which was not available before. So if I do that and save, then if I go back to actions, then a new workflow will start, which will take what I have on the branch GH Pages, which is my render documentation, and actually publish that on GitHub Pages. And you see that there's a new workflow here that is happening. See, the build took 5 seconds, build status took 3 seconds, and now it's deploying. So it doesn't take very long typically. And we are almost out of time. So, but let me show you this. Okay, so now I have some documentation, which is an empty project here, and it's shown on GitHub Pages, so it's visible to everybody. So if you go to this, if you go to this address on your browser, you will see what I have just created.
Yeah, so this is really neat, and so I mean all of these steps that you showed here with this YAML file and the actions. I mean the things that you were activating on GitHub here. These are things which are, so to say, living on GitHub. There are corresponding things on GitLab and on Bitbucket and so forth.
Unfortunately, the syntax is different. Actually, on GitLab is much simpler, and there's also a guided procedure if you have a repository on GitLab. But anyway, you get the idea, I guess. I hope that the idea, the hope here is that you get the idea that you can. Yeah, these platforms, GitHub and GitLab, give you this opportunity to host static websites, which you can generate with Sphinx or other projects or other tools. So, shall we go to the notes and see if there's anything we need to discuss or anything that we can? Yeah, we have 3 minutes for conversation.
There is, starting with the last question here. So are there limitations to being able to use this with private repositories? And last time
you can't. I think you cannot on GitHub.
Not for free.
Not for free, yeah.
But if you pay for it, enterprise and so on, then yes.
If you are an academic user, do you qualify for Pro anyway? So I guess it depends. So if you register with an academic, it used to be that if you registered with an academic email address, then you would be automatically considered in the pro tier, so you would be able to have that. So, but
I'm not really up to speed what was currently the offering from GitHub, but in general, I mean, you get some of it a little bit for free, and if you want more capacity, you need to pay for it, which is rather reasonable. And that's something actually that we will come to tomorrow in the testing lesson, because the rendering of the Sphinx document that Michele set up here to run on GitHub, that's rather lightweight. This is sort of, you only need a little bit of hardware on the server side here on GitHub to render the HTML and then also to host it. When you come to things like testing and the so-called continuous development workflows, where you might then run big tests, then more hardware is booked for longer time, and there you will also have this situation where you get a little bit of capacity for free, but if you want to do more heavy stuff, you need to start to pay for it monthly.
There are ways out of this, but they can be a bit harder to set up. So. But it will be discussed tomorrow.
Yeah. So so we will not. So now we showed it here on how to get it up on GitHub Pages, and you find in the lesson material that you can do similar things then on GitLab and also on Bitbucket.
Yeah, I never used Bitbucket. I have quite some experience with GitLab. The only thing is that GitLab allows you to have private, let's say, pages, but they need to be activated centrally. So your GitLab instance may or may not have the pages feature activated. So yeah, some of servers they have. So GitLab.com for sure. But if your institution has their own GitLab server, well, you need to check if the page is available there.
Yes.
And the feature.
Yes, indeed. So many institutions do have their own instances of GitHub or GitHub servers, and then you can work with them within, let's say, within all of your organization, and perhaps also with some partner organizations. Good.
So now we are going to have a lunch break, and we'll be back with I will be back with Jarno talking about Jupyter notebooks. If you have questions, you can still ask in the notes in the collaborative document. We'll try to answer them anyway. And well, I mean, if you want to join the bring your own code sessions in the future, well, I think documentation is also something that can be discussed there. So with you personally, let's say.
Yeah.
So what can I say? Bye.
Yeah, good. So thank you, Michele, and bye everyone.